So in this video here, we're going to get an overview over like what is object detection, what can it be used for, and how does it actually like work. So basically like object detection is that we want to find specific objects in the scene. So there's also some other different kind of like problems that we can solve where we, for example, like have classification, we have object detection, we have some segmentation, like semantic segmentation, instant segmentation, and so on. But the basic idea here behind object detection is that we have an object in our image, and then we want to draw like a bounding box and detect that object in the scene. And then we also need to know how confident are we that this is actually like the object that we want to detect. So basically like object detection is really good for some real life applications. If you have some, for example, like a packaging system, or you have like a warehouse where you want to detect different kind of things, or maybe like a conveyor belt where you need to like do some pick and place tasks and so on, we will probably have like an object detector detecting those objects on like a table or like on a conveyor belt running. So you can use for a lot of different kind of applications, and it's actually like really good because you can actually like identify where are things in the image, and you can also identify like specific things. So this is not just a classification problem. So here we're not just classifying that there is a horse in the image, but we actually like detect where is the horse exactly in the image. And this can be used for a lot of different kind of things, and we're going to cover like way more throughout this course, how it can be used and also how it's done. And then we're also going to talk about the YOLO V7 model. And also the architecture of the YOLO V7 model, because it can be used for a lot of different kind of things. But object detection is really good to know, and also just the whole process here that we're going to go through with this course, where we have like our data set, we generate our own data set, so this can directly be transferred to like a project or some real life application that you want to implement, like in like a factory production line or something like that. Or if you just want to do some research where you just want to go from generating a data set, label your data set, train your model, deploy your model, and then you have a really cool project up and running. So basically here, we're just going to cover like object detection. We're going to see how we can detect different kind of objects. In this course here, we're going to detect different kind of like COPs. So I'm going to show you how we can actually like generate a data set in another video. But here we're basically just going to take some different types of COPs, and then we're going to like detect each of the individual COPs. We're not just detecting that there's a COP, but we're detecting what type of COP is actually like in the image, and also where. So here we're just going to see some results from the YOLO V7 model on the COCO dataset for object detection. So here we can see down on the x-axis is actually like the inference time. So how fast does it actually like pass an image through the model. So the better, like the smaller inference value, like the less time it actually like takes to do inference and make a prediction with our network. So the closer to the left here on the axis, x-axis, would actually like be better, and also here on the y-axis, the higher like average precision it has, the better. So we actually like want, like ideally we want a model that is all the way to the left and as high as possible. And here we can see some different kind of like YOLO models that is compared. So we both have our YOLO V5 model, which was this like last state of the art before YOLO V7. So YOLO V7 here, as we can see, is just way more performance. So the idea behind like creating YOLO V7 was actually like over like YOLO V5 was actually like to generate a model that can do fast inference without losing accuracy. So this is basically like the idea and the goal for like every model that comes out. We want to make the model faster, and we also want to make it better. But here we can see that it actually like both makes it better and also faster. So here compares YOLO V5 with YOLO V7. We can see all the way over here to the left. So they have different kind of like models within each brand. So they have like some different kind of like different sizes of the models. So here we can see like the best model that YOLO V5 has is actually like around 55 average precision on this COCO object detection dataset, where we can see this model here from YOLO V7 is actually like at the same accuracy, but it's up to 2.5 times faster than the YOLO V5 model. So you can actually do way more processing with the YOLO V7 model compared to YOLO V5. And we can also see with some of the larger YOLO V7 models, we actually like get way higher accuracy. So here we are up around 57 in mean or like in average precision, where we still have pretty good inference time. So here we're around like 25 milliseconds per image passed through the model. We're over here to the left. If we just compare the best results from the YOLO V5 model, we are like 120% faster. So it means that we can now do inference in around like 12 milliseconds instead of up to here to 26 milliseconds. So an improvement of 120%. So here you can see that it just compares it to some other different kind of models as well. We also have YOLO R, which is a pretty good model as well. But again, we can still see it has better precision and it's also faster when it's doing inference. It also compares to like YOLO X and all these other different kind of like models that is not as good. So here you can see the best models are definitely YOLO V5, and then we have YOLO R, and then we have YOLO V7, which is the new state-of-the-art model for object detection. And you're going to see the crazy results that we're going to get at the end of this course here, and it will actually like be way better when we deploy the models with OpenCV on a live webcam.